Hey guys, want to spend a few minutes talking to you about atmospheric pressure, but before that, let's see actually what the effects of atmospheric pressure are. So these are just some videos I found on YouTube, and I'll just let them play through before we talk about what's going on. This one does not have sound that's playing right now. The next one actually will, so prepare yourself for slightly cheesy music. Hooray for time-lapse. Maybe not what you were expecting there. This one, prepare yourself for cheesy music. It's the same principle.
760. Gewonnen hat Herr Dr.
So what we've seen are these two gigantic metal structures completely crushed, seemingly by nothing. One of the YouTube comments on this particular video said, yeah, if I was an invisible giant, I'd sit wherever the heck I wanted to as well. But it does look like some invisible force has just crushed these, and we tend to think of wanting to see something having done that. But in this case, it's nothing but atmospheric pressure. So let's talk about what's going on with this first one. First, with atmospheric pressure, we have above us this gigantic column of air that extends for miles above us. And even though air doesn't have much mass, and it's not very dense, when you have several miles of it, it starts to add up. And so you have literally the weight of all this huge column of air above you pushing down on you all at once. And this is not just on you, this is on everything. We are at the bottom of an ocean of air. And what that does is that creates a huge pressure, force distributed over an area. And that pressure is about 14.6, so we can round this off and say about 15 pounds per square inch. Now if you take your knuckle, gotta line it up with the camera, there it is. That right there is about 1 inch. So think about a square that has those dimensions, so something like that. On every space like that, the air exerts almost 15 pounds of force. So over the course of the area of your body, this amounts to a huge amount of force on you. Typically, we don't notice this because inside our bodies, there are forces that are pushing outward with exactly the same pressure as the air pushing inward. We're designed this way. Nature has allowed us to have these mechanisms to equalize pressure. Otherwise, you can imagine somebody walking down the street and losing pressure and this happening to them. That would make the world a much more horrible place. You watch a squirrel in a tree and all of a sudden it implodes. Nobody wins in that. Luckily, nature has equipped us better. So we don't have to worry about air pressure doing to us what it's done to this drum because we have an equalizing pressure outward. Think about times where your ears have popped, maybe on an airplane ride, say. What's happened is that the pressure has changed from what you're used to. So the pressure may have dropped at that altitude, and what happens is your body has to equalize that. You end up with more pressure on the inside of your body than on the outside of your body. So to relieve that, your ears pop and release some of that pressure. Now, let's talk specifically about what's going on with this poor 55-gallon drum. So what they've done is they've taken this stove, and then you take a 55-gallon drum and you put just a little bit of water. You don't even have to put much in it. And you heat this up until the water boils. So the water boils, turns into a gas, and it drives the air out of the drum so that the only thing left inside this 55-gallon drum is just water vapor. So now they cap it off, sealing the water vapor inside, and they put it in this water ice bath. So it's a kiddie pool that has ice in it. And what this does is this cools off the water vapor and turns it into a liquid. So if you were to listen carefully and you were here, you could probably hear drops of liquid falling inside this drum at this time. And then, once a sufficient amount of that water vapor has turned into a liquid, There's no air inside this. There's no water vapor pushing out. There's nothing to equalize the air pressure. And so the air pressure simply crushes it. There's nothing left to fight that. There's from a different angle. I know from here it's kind of hard to see exactly what's happening. From here, not so much. The same thing happens with this tanker car. All that's been done is that, and I would imagine this is probably done through that hose right there, is that they have evacuated the inside. There's much, much less pressure on the inside, and now all the pressure that was always there from the outside does its work and completely crushes this. So yes, there's a huge amount of pressure on you from the air, and it's from this huge column of air that exists above you everywhere you go on Earth. But we don't have to worry about this happening to us because our bodies are equipped to handle this pressure. We only really notice it when you have situations where that you don't usually see. Say, for instance, an empty tanker car that doesn't have the inside pressure to contain it. The world is a fantastic place, more strange than maybe we can even imagine.